Hi everyone, welcome to Om Learning Lab. Today we are going to solve the problem best time to buy and sell stock. This is one of the most famous problems asked in coding interviews. It has multiple versions and each version becomes tougher than the previous. We will cover all the versions one by one. In this video, we will be covering the first version, which is the easy version of the problem. Without any further ado, let's begin. You are given an array prices where prices of I is the price of a given stock on the ith day. So we have an array and every element represents a price. And you want to maximize your profit by choosing a single day to buy one stock and choosing a different day in future to sell that stock. So we are supposed to pick a couple of days which are different. They have mentioned it explicitly, different day in the future to sell. So one day we buy, one day we sell, and this profit, the difference has to be as maximum as possible. And if any profit is not possible, we return 0. So in this case, obviously profit is not possible, right? Because it is descending in nature. So if we buy one day and sell in any day which comes after the given day, it will be negative, right? Because it is descending. So here we'll return 0. So fairly straightforward problem. Let me just take the first example and try to explain the approach. So we'll solve this using basic approach first for this particular version of the problem. And for the subsequent versions, I'll make separate videos. So it is highly recommended that you go through all the videos one by one. And from personal experience, this same question has been asked to me across 3 different companies. And usually interviewers keep on asking one version after the other. They want to see how much knowledge you have, how much depth you have regarding the problem. So please go through the videos one by one. Now, coming back to the solution, let's take this array 715364. Let's open up the notepad. So what do we have? We have 715, 715, 3, 6, and 4. Now, basically what the problem asks me to do is, you pick two indices I and j. I cannot be same as j. It has to be different, they have mentioned. And I is less than j. Let's say I buy on the ith day, I sell on the jth day. And this difference, value at j minus value at I, should be as large as possible. That's basically what the problem wants me to do. Now, if I observe here, let's pick a different color. Let me pick blue for this. If I observe here, if I want to maximize this, it obviously makes sense to minimize this. We want to minimize the purchase price as much as possible. Think of it in a real life scenario as well. If you want to make profit in any transaction, you will want to make your buy price as less as possible, right? You wouldn't want to spend a lot of money in the buying price, right? You want to get more out of it. The selling price, this quantity has to be high. This has to be as high as possible. And this has to be as low as possible. Now, keeping that in mind, one should be able to note that we can track the buying price as we iterate on the array from the left. So let's say I declare a variable called buy and I start iterating. So in the 0th index, my value is 7. So I'll just assign 7 to the buying price. Now in my first, when I look at element here on the first index, so we have 0 based indexing. So these are the indices. Now here, if I look at this particular element, the value is 1. Now I cannot make a profit, right? So current buy price is 7 and I have 1. 1 minus 7 is negative. So I cannot make a profit. But what I can do is, for all the remaining elements that I am going to see from this point onwards, I can make 1 my buying price. Because the argument is, for any transaction, if I have a buying price of 7, it always makes sense to have a buying price of 1 instead of 7 because 1 is lesser, right? This is the idea. Keep the buying price as less as possible, as low as possible. So I will change the buying price to 1 here. Basically, we'll iterate on the array from left And we'll have a variable called by, which will store the least element we have seen so far, because it is always optimal to keep the buying price as low as possible. Then we go to index number 2 and I see the value of 5. So, okay, 5 minus 1 is profitable. Please note that if I had kept the buying value as 7, we would be encountering a loss. 5 minus 7 is minus 2. But we have flipped it. We have changed the variable by to 1. And it makes sense, right? We want to keep the buying price as less as possible. So now 5 minus 1 is profitable. So we'll also have a variable called profit. So this is the first value of profit we got. So we'll initialize it with 0 because as they have mentioned in the problem, if we are not able to make any profit, return 0. So we'll initialize the variable with 0. Now 5 minus 1 is 4. So we'll make 4. And we will not be updating the minimum value, by the way, because 1 is still lesser and it makes sense to keep the buying price as 1 because it is less. We want to keep it as low as possible. Selling price should be as high as possible. Now I go to index number 3. I encounter the element 3. 3 minus 1 is 2. 2 is not more than 4. So we will not be updating profit variable. I'll go to index number 4. I'll encounter 6. Now 6 minus 1. Remember, the current buy price is still 1 because it is the least element we have seen so far. So 6 minus 1 is 5. 5 is more than the current profit, which is 4. So profit value is no longer 4. It will be updated to 5. Then finally, I'll go to the 5th index. It has 4. 4 minus 1 is 3. 3 is not more than 5. Hence, there is no update and the final answer is 5. This approach is fairly simple. Let me just go through it once again. Basically, what we want to do is we want to maximize a single transaction, which means the buying price should be as low as possible, selling price should be as high as possible. Hence, as we iterate on the array from left to right, we will maintain a variable called by, which will store the least element we have seen so far, because buying price should be as less as possible. Then, as we keep on encountering elements, we'll compare that value with the buying price. And we'll compare the given profit we are getting. So here initialize the buying price with 7, profit with 0. Then I encounter 1. 1 minus 7 is negative. We will not be updating the profit. However, 1 is lesser than 7. Hence update the buy price to 1. It is always optimal to have buy price of 1 because it is very, very lesser. It is quite less than 7, so to speak. And then keep on repeating the step. Encounter the other elements. Compare the profit. Compare if it will give a lesser buying price or a more profit, and so on and so forth. 5 minus 1 is 4, update the profit. 3 minus 1 is 2, don't update the profit. 6 minus 1 is 5, 5 is more than 4, hence updated. And finally, 4 minus 1 is 3, which is not more than 5, hence no more updates. And the final answer is 5. This is it. This is quite straightforward. And we can also implement it. So I'll be implementing it in both C++ and Python very quickly. It's very easy to implement. Let me just go ahead and quote it fast. So we have a vector of prices and let's declare n as, let's say, the length of the array, which is prices.size. Then what I want to do is let's declare the profit as 0. So the initialization part that I was mentioning about in the notebook. Then what I want to do is I'll be iterating. Let me just initialize the buy value as prices of 0, the first value, because we cannot sell on the first day, right? So first day can only be a buy. So just assign it to the buy variable. Then we'll just iterate over the array. I is 1. So we'll iterate over the rest of the elements in the array. I is less than n, I plus plus. So what we're going to do is profit is maximum of profit, or whatever is the price currently, minus our buying price, this. So profit gets updated and we'll also update the buying price. We'll make the comparison with the current element. So it is minimum of whatever is the buying price or the current price. Right. So for every element you encounter, you first check how much profit you are getting for the current transaction, for the current buy price and the current element as the sell price. Then you also compare that the current element, can it be a better buy price? That's exactly what we did here, right? So initialize buy price with 7, then iterate over the array, compare the profit. If it is profitable, then update the profit, and then also check if the current value can be a better buying price if it is lesser than the previous buy value. That's all. I think this should work. That will just return profit. That should be it. Let's see. Accepted. Is there any side test case where it might fail? Can there be one element? Okay, so prices, it can be one element, but if it is one element, will not be iterating. Will it be iterating? No, I don't think so. We won't be iterating. I think it should be fine. Let's see. Okay, so it got passed. We'll do the exact same thing in Python as well. I'll not be making a separate video this time because it is fairly simple. So we'll initialize profit as 0, and let's have a variable called buy price, which is prices of 0. Then what we can do is, let's call it for I in range. So we'll use the range function to iterate from the second element to len of prices. We'll iterate over the array and we'll do the exact same thing. Basically, profit is, I don't know if max function works or not in Python. We just go for it. We'll update it if it doesn't work. That's okay. So it is max of the current profit and prices of I minus the buy price. And similarly, buy is minimum of the current buy price and prices of I. Finally, you return the profit. Let's see. It gets accepted. So maybe min and max are valid functions in Python. Let's try to submit. Oh, accepted. So that's all for this video. The concept is fairly simple. This is actually the easier version of the problem. So in real interview scenario, if you are able to solve this version, you are definitely expected to solve this version. And once you do so, interviewer is definitely going to go to version number 2. So please do make sure to watch version number 2. I'll add the link of version number 2 in the description of this video. Go and check that out. This is all for this video. Thank you.